In this NeuroSolutions Tip Box, we will be discussing solving problems with large data sets. For this example, we will be using an OCR dataset where the images have been pre-processed to give 16 different edge detection measurements to classify each of the 26 capital letters. By pre-processing the images from pixels into these measurements, it eliminates feeding thousands of pixel values, which is not the optimal way to solve this kind of problem. Today we are going to look at online versus batch training. In NeuroSolutions, you have three options in the back controller. Online learning updates the weights after each exemplar or sample. Batch learning updates the weights after each epoch. And finally, custom allows you to choose in between batch and online to a user-defined value for the number of exemplars. Online learning is typically good for large data sets, which makes each epoch longer to run, but it should also solve the problem with fewer epochs, and also it is less prone to getting stuck in a local minima. A couple of things to keep in mind with online learning is making sure that your data is randomized, so that it does not focus on one type of the problem and then forget it by the time it reaches the end of the data set. The other aspect is to keep your step sizes low, so that you do not have similar tracking issues as I just mentioned. For small to medium-sized data sets, batch learning tends to train the fastest, but it can also be slow for large data sets as the gradient averages out all to zero, which makes it easier to get stuck in a local minima. Now, let's go ahead and take a look at NeuroSolutions and compare online versus batch against our OCR dataset. By clicking on the Back Static Control Inspector, we can see that batch is selected by default. So let's go ahead and start the network. Immediately, we can see that the confusion matrix is jumping around, though it's not classifying any particular letter that well. The error is declining, but it is not really declining at a rate that is going to solve this problem. So now let's go ahead and try changing this from batch to online learning. Let's pause the network. Again, in the Back Static Control Inspector, we'll just select online, reset the network, and press start. Immediately, we can see that there is pretty significant oscillations in the learning curve, which should not be present during momentum learning. Oscillations are common with other learning algorithms such as Levenberg-Marquardt, but not for momentum. So what this tells us is that we have our learning rate set too high. Because since we are updating after each exemplar, we do not want to overcorrect for each piece of data. To adjust this, let's go ahead and pause this network, and we'll bring up the properties for the momentum component. By default, the step size was set to 1, but we want to reduce this by 90%, which is also a factor of 10. And this will affect all of the momentum components. Now, if you do look at the other momentum components, you'll notice that the step sizes are different as you go from left to right or right from left. The reason the numbers are typically lower on the right side, which is closer to the outputs, than on the left side that is closer to the inputs, is because that the weights typically decay as they backpropagate through the network. So now let's go ahead and run the network with the lower step sizes. First we'll reset it, and then press start. As we can see with the lower step sizes, we're starting to see some resemblance of the letters being classified appropriately. However, there's still a little bit of oscillation in the learning curve, which should not be present. We're still at a significantly better rate than what we were with the batch learning, but let's go ahead and lower the step size again and see if we can improve that further. So let's go ahead and pause the network, go back to our momentum components, and reduce that by 90% again a factor of 10. We'll go ahead and reset the network and press start. So now looking at the learning curve, there's no oscillations, and it's definitely a learning curve that we'd like to see. It's definitely much smoother, and we can already see that the error is significantly better than our previous runs. In addition, the confusion matrix is actually showing a good percentages for each of the letters being classified. Using momentum in online learning is a great trade-off for datasets that are simply too large for learning algorithms such as Levenberg-Marquardt. especially if your computer doesn't house a NVIDIA graphics card for CUDA processing. We'd like to thank you for taking the time to view this NeuroSolutions Tip Box. If you should have any questions, please feel free to contact us at support@nd.com. You can also view other NeuroSolutions Tip Box videos on our website at www.neurosolutions.com or on our YouTube channel